OK. Like many of the protocols we've talked about, TLS starts with a handshake. Now, this is kind of an involved handshake. It's got a lot of steps, and it needs to achieve all of the cryptography properties that we've talked about. So we'll take it slow, one step at a time, and then we'll come back to the handshake to think about why our design achieves all of the goals that we talked about. But be warned, there's a lot of steps, and we'll go through them slowly. OK, so here comes the first step. The first thing we'll do is exchange some hello messages. Now, before we even do this, maybe you can think of this as step 0. Remember that all of this is happening on top of TCP. So if you're worried about the client hello being too long and needing to be split up into packets, not our problem, TCP's problem. And what if client hello gets dropped? Also not our problem. TCP will handle resending the packet. So we already have the TCP connection. We can send whatever we want back and forth, and it will arrive in order reliably. TCP takes care of that for us. So with that step 0 out of the way, now we can start sending data back and forth. So the client's going to send a client hello. The server's going to send a server hello. Each of the client and the server will pick a random number and exchange those. So the client chooses R sub B, sends it over. Server chooses a random R sub S and sends it over. And R sub B and R sub S, as we'll see later, will help us ensure that two handshakes are never identical. If you do 2 different handshakes, these will have 2 different values. So the rest of the handshake should have different things happening. That's going to help us later with replay attacks. So as a bit of a preview, that's why they're there. But for now, it's 2 random numbers. Now, in the hellos, the client and the server will also negotiate some algorithms to use. So the client will say, here are some cryptographic algorithms that I support. For example, I support SHA-2 as my hash, or I support HMAC, or I support AES CTR mode. And the server will reply with their choice of algorithm. So it could be the case that maybe these 2 want to use AES CBC, but these 2 want to use AES CTR in their connection. So in the hellos, they get to negotiate and choose their favorite cryptographic algorithms as well. That's step 1. Now here's step 2. This is the step that's going to start helping us validate who the server is. Remember, we have to make sure that this is the real server, and it's not some random person impersonating the server. So the first thing we'll do to help us make sure that's true is we'll have the server send its certificate. Now, what is a certificate? Remember, I don't really like this name. I think it's not quite clear what it is from the name. But remember, a certificate is nothing else but the server's public key signed by someone we trust, some third-party authority that everyone trusts. So this certificate just says the server's public key is this, and someone signed it. For example, it might say google.com has the public key this, and all of this message is signed by someone that I trust. So once the client receives it, they can validate the signature to make sure that this is truly the public key of google.com. So at this point, what does the client know? The client knows that the server's public key is this value. And they can be confident about this because, remember, the certificate is signed by someone they trust. So if they verify the signature, they know for sure, this is google.com's public key. I am 100% sure of this fact. Does that mean you're really talking to Google? Maybe. Maybe not. Remember, certificates are public. It's just someone's public key with a signature on it. So anybody can provide the certificate. At this point, this could still be some impersonator sending google.com's certificate, and the client doesn't know any better. So we're not all the way there yet. We're not 100% sure that this is google.com yet, but we've taken that first step. We know google.com's public key, and that's going to help us later. So this is step 2. We've obtained google.com's public key in the hopes of trying to validate that this is Google. We're not all the way there yet, but we've started the process.